And that was all illustrious career number one. In his second career, which is just now getting started, our speaker today has become the most vocal exemplar of an AI scientist who has changed their mind. In response to rapid progress in the field of AI, today's speaker wrote that he is concerned that we may not be on a good course and that major changes are needed to reap the benefits of AI and avoid catastrophic outcomes. He's recently made founding strides in this direction, including at the recent UK AI Safety Summit and setting up some fledgling AI policy and establishing a basis for international cooperation on AI. He's also written extensively about the technical basis for the AI alignment problem. So it's my honor to introduce Professor Yoshua Bengio.
Thank you. Thank you for the kind words. Before I really start, let me summarize some of the main points I want to make today. AI is becoming very powerful, and it'll be even much more in coming years. And an important question is it going to be companies who decide by themselves what should be done with it, what is acceptable and what is not, what is moral in its use or its development, or is it a democratic process? So that's the first message. The answer should be obvious, but apparently it's not to many people. The second message is more technical. The way that we're building AI right now, the most powerful ones, in particular when we're using reinforcement learning, has a technical flaw in it that is likely to yield a loss of control, that we might have machines that actually do not do what we want, in fact, might not care at all about what we want. And what's really troubling with this for computer scientists is that the more powerful we make the AI, the bigger that problem is going to be, the harder it's going to be to make sure it behaves as we want, it is aligned. And so I'm going to suggest at the end that we need to do research. I'm going to suggest some research directions to obtain exactly the opposite property, which I think we should all look for, which is that the AI safety would improve as we throw more compute at the problem rather than the other way around. Okay. So a few words about AI alignment. Simply, it's what I said when I said we want to build machines that behave according to our intentions. Right now, we don't know how to do that. What we do is we specify what we want, for example, with feedback with LLMs, with rewards, or with imitating how humans would behave in different situations. And we use natural language instructions. None of these things, unfortunately, really achieves the goal of making systems that perform as intended. And a fundamental reason for this is that we don't know how to put in a clear formal language a kind of definition of harm, or whatever kind of harm that we care about. So there's no like formula we can write down that we can then have computers check to see if some action could be dangerous. And in fact, there's now a lot of documented examples that all of the things we've tried up to now with various kinds of LLMs to try to make them safe can easily be breakable. And that not only that, these systems will be confidently wrong in some of their decisions. And so, this is a problem I'll come back to. Before I go there is a few words about safety in general. Technology is generally dual use, could be used for good, could be used with malicious intentions. And the more powerful it is, the more this dual use aspect is something we should worry about. So really important conclusion here is that there's a threshold somewhere or of a particular kind of AI that could be dangerous, for which we need democratic oversight. And in particular, one fundamental reason why we have to worry here about misuse is because these machines will just do what we ask them to do, whoever asks them to do. So fundamentally in AI, it's possible to decouple the intellectual capacity from deciding what the goals are. And that decoupling is dangerous, because if the person making the requests has goals that are dangerous for society, then we all kind of could lose. In addition, there's the problem I've come back to, that there are different scenarios in which, even if we wanted to produce good objectives, we could lose control. So we should really think hard about how we avoid that, and minimize all those risks. Now, there is a particular way in which we could lose control, which is very simple to understand, and there are more complicated ways. But I'm going to start with a really simple one, which is somebody just gives as a goal to the machine to preserve itself. So that this self-interest or self-preservation goal is a thing that every living entity on this planet has. Evolution has put that in us. Okay, so if we had entities that wanted to preserve themselves, then that means if we wanted to turn them off, for example, they would try to avoid that, they try to resist it, try to copy themselves before we do that on many computers. And so having a self-preservation objective opens the door to conflicts that could be bad for us if these entities surpass us in enough ways. They don't have to be smarter than us on everything, just enough ways to be creating harm. So some people say, well, forget about all this discussion because we'll never have machines that are smarter than us. But actually, the scientific evidence suggests that it's quite possible that we will build machines that are smarter than us. Brains are just biological machines. And in fact, there's no reason to think that they're the smartest possible thing out there. In addition, as Jeff Hinton has argued nicely in a talk last May, and he keeps repeating, digital computers have advantages over brains because of the digital versus analog hardware, which allow them to have more precise memory, to parallelize computation thanks to communication bandwidth that's like millions of times greater than our communication bandwidth between humans. And so that's the reason actually already things like ChatGPT know much more stuff, that they can read tens of thousands of times more stuff than you or I could read in our lifetime. So I think we should be concerned about this possibility and make sure we don't suffer from something like this. The second biggest problem, and we can't like really decouple these two problems, is power concentration. And I mean this in a kind of general sense. So to understand what I mean, simply when we build very powerful tools, and we will build more and more powerful AI, whoever controls those tools gets to have more power, because intelligence gives power. And by the way, democracy is the opposite of power concentration. And so we have a problem. Like, if we want to have democracy, we need to strengthen the democratic governance to avoid the misuse of this AI power to dominate economically or socially or militarily or politically or whatever. And that remains a problem even if we solve this safety and alignment problem. In fact, it might make things worse, because those who do it will not be afraid that it blows in their face. Another related question is that in order to regulate AI, to be able to have a democratic process to decide how we use it, governments need to acquire the capability to understand it, to master it, to even use it to defend themselves. So I've made 3 main recommendations to the US Senate last July, and I'll go just high level here. One is around regulation, and in particular, making sure that the governments are able to put red lines to control who can access these things, and and that they behave according to the democratic will. The second is that we need to understand much better these harms and these potential risks. So we need a lot more research in AI safety. We need governments to invest in this, and through universities, for example, but also we need companies to have the incentives for that. So one thing I've proposed along those lines is that companies should have the burden to demonstrate that their systems are safe before those systems can be deployed or even potentially built. That will give them a great incentive to do a good job at building safe systems, just like we ask for, in other sectors. Like pharma cannot put out a drug until they have demonstrated to the regulator that their drug is not toxic. And then the last recommendation, I call it countermeasures. The idea is, well, sure, we should do treaties, we should do regulation, but they're not going to be 100% foolproof. So we should also prepare, governments should prepare against the possibility that there will be some dangerously powerful AI out there, either controlled by humans or that we lost control of, and prepare countermeasures. Okay, so let's focus on the technical aspect now. What is it that makes a powerful AI not safe? Well, it needs to be powerful enough, otherwise it can't do a lot of harm. It needs to have agency, meaning it can act in the world in ways that could harm. And third, it needs to be misaligned or in the wrong hands, which are two variants. But so this misalignment I talked about already. And I'm going to argue that some of the ways we are currently training them with reinforcement learning actually amplifies the misalignment. So why is that? You have to understand how reinforcement learning work, but roughly speaking, there are two parts of a reinforcement learning system. You've got the reward function and you got the policy. And the policy is going to be optimized to maximize the rewards. So if the reward, and where do we get the reward? Well, as I said, we can't write formally exactly what humans want. And there's no chance we'll be able to do that anytime soon. And so we're going to approximate the reward that we want to give the machine for its behavior. And there's going to be a mismatch between the true reward that humans would like, if even such a thing existed, and what the machine understands that it should be doing. And then it's going to optimize its policy to maximize the reward. The problem is that as it's trying to maximize something that is not quite right, it's likely to discover the biggest mismatches. It's going to amplify the misalignment. And I have a figure to try to illustrate it. So let's say that the red figure is what, there's a typo. The red curve is what the machine thinks is the reward, and the green one is the one that we want. When it optimizes, it's looking for some configuration on the x-axis that maximizes its estimated reward, and it's going to find some weird places where the reward is really high, but it's too good to be true, and it might completely decouple with what we actually want. And these kinds of rare places can only be discovered through a sort of optimization, which is how it's trained. If we just do a random testing, like a normal test set as we do in machine learning, we might not discover these special ways for the machine to act that would decouple its behavior from what we want. And this is a problem because the way we're currently evaluating the safety of an AI system is by spot checks. We are like, trying to find places where its behavior differs from what we want. And those spot checks, it's not clear that they would discover all of those bad places where the system would decouple from what we want. To be more concrete about decoupling from what we want, let me mention the notion of reward hacking. So imagine that the AI doesn't quite understand that what we want isn't what we type, but it's something that's happening in our head. And so that it tries to make sure that the keyboard that is used to give it positive feedback is going to be always giving it positive feedback. So it could do that, for example, by hacking the computer where this is happening. And then once it got to control of that computer, it doesn't care about what we really think, right? So this is an example of a very weird strategy, very unlikely to find by chance strategy, but that by optimizing the behavior of the AI, it could discover this sort of, I can get all the juice I want by doing some very special strategy, but it's not what we want. Okay, and there's a really nice paper by Michael Cohen, Hutter, and Osborne that explained this and how it's not obvious how to fix this. So now I'm going to give you a high-level pitch for the general direction I think might help us to deal with this and the problem of alignment more generally. I'm going to claim that a lot of the problems come from having an AI system that has not a good self-understanding of its own lack of understanding. So this is called epistemic humility. We would like an AI system that, when it's not sure, behaves conservatively so it doesn't, harm people. Now, the way we're currently training them is with reinforcement learning or maximum likelihood. And what that does is it's going to pick one of the functions that fits the data. There are usually an infinite number of ways to fit any kind of data set. And so the problem is, one of them may be right and the others are wrong, and we don't know which one. So if you just pick randomly one of the theories that explains the data, you might actually have a very bad theory. So I illustrate this with the example here, like toy example. You've got a robot and it's in front of two doors, the left and the right door. And based on all the data that it has seen, there are two theories that survive that are compatible with the data. So the left theory is one where it thinks that if it goes to the left door, it's going to die. If it goes to the right door, it's going to get some cake. The right theory says, if I go to the left door, I get some cake. If I get to the right door, nothing good, nothing bad. So what should you do? If you're trained in the current ways with maximum likelihood or reinforcement learning, you might randomly pick one of the two. And if you pick the wrong one, well, then you might die. So is there any other option, right, that would be more conservative? Well, you keep track of all the theories. This is essentially what Bayesian methodologies are about. And you know that you don't know which one is correct. And so you're going to take the right door, because there you might get some cake or you might get nothing. So that's the reason why we need a kind of Bayesian approach in order to build safe systems. So you might ask me, like, why is it that we're not already doing it? And why is it that not all of machine learning is based on these Bayesian stuff? Well, because the calculations that are needed, the Bayesian posteriors, as we call them, are computationally intractable. And the approaches that have been used in the past to build Bayesian approaches generally make too strong assumptions that end up, with systems that don't actually work that well in practice compared to the maximum likelihood methods. So is there any solution to this? Well, I claim that there is maybe a way out of this by using advances in machine learning in recent years, using what's called learned amortized inference, where, for example, we could train a neural net to approximate the Bayesian exact distance. All right. So I'm going to just mention quickly that we've been working in the last few years in my group with a method called GFlow nets, or generative flow networks, that have this property that if you give them a reward function, so they're like reinforcement learning methods, but if you give them a reward function, they will not try to maximize it. They'll try to sample the objects of interest proportionally to that reward function. And if you choose the reward function as what we call the prior times the likelihood in my jargon, then you get the Bayesian posterior. So in other words, there's a way to define an objective function for training neural nets that has a property that when we get that objective function to be minimized, we recover the Bayesian posteriors that we need. So one like high-level scheme to implement this is that we're going to use two AIs. The one that you could call the agent, and we can train it in any way we want. And another one, which I call the AI scientist, which builds a Bayesian model of how the world works, and in particular of the harm that could happen if you take a particular action. And then when the agent proposes a particular action, the AI scientist would estimate the probability of harm. So if there's any of the theories that are compatible with the data that give you a really bad outcome, then we should decide not to follow that action. So it's instead of having a spot check on the trained system, we are saying for each action of the AI that we want it to be safe according to a Bayesian estimation, which is going to be very conservative and take into account all the possibilities that could explain the data. And so I have this conjecture that with this sort of approach, as we make those neural nets bigger and train them longer, they will approach the Bayesian posterior, and you will get safer solutions. Sorry for all the interruptions with the screen. I'm getting this. I'm going to stop here, and I'm happy to answer your questions.
Okay, wonderful. Thanks so much. Okay, so now we're going to spend the rest of the time on Q&A. I'm going to kick things off with the first question. So Professor Bengio, there's a question that we often get asked, which is something like, man, like the way we're training these AI systems isn't with some like hard-coded reward function. It's like we're like the reward function is human approval. And we often get asked, like, you know, naively, we're just like, you know, we're training them to do things that we like. We have full control over the reward signal. Like, so what concretely is the thing that goes wrong here? Yeah, so I would love to hear your answer.
Yes, yes. Well, what goes wrong is that based on the finite amount of feedback that we give it, there are a lot of possible reward functions that could fit that data. In fact, if you go to causality theory, there's even if you had infinite data, you would still have some uncertainty about what the right theory is in general. And so, if as I was trying to explain, like that mismatch, that imperfection, could be then amplified by the process by which we train it, because it's trying to maximize those rewards, and it's going to find some weird, you know, too good to be true solution, which is, you know, might not correspond to what we want. And the reward hacking is a sort of example of that, where it takes control of, you know, it wants to maximize this reward function, so it finds a way in the real world to get that reward, and it might not correspond to what we actually want. Like it could convince us to say this is good using some drugs or whatever, or convincing us through influence, or it could take control, you know, through cyber approaches or something. These are like simple ways of thinking about the problem, and there's a lot more elaborate thinking that has gone into some of the papers I mentioned and others.
So one follow-up. So that's a great answer. A common follow-up that we get is, well, okay, so now estimating the reward is some completely standard function approximation problem. We already know deep networks have like very nice empirical generalization properties. Is there a reason that we, even when the data never fully specifies the function we want to approximate, but it often goes well anyway? Is there a reason we're especially concerned in this setting, or is it that we want to be especially conservative here, or like what's making this different from typical?
Well, yeah. So the approach that we currently follow, we're looking for one reward function, which is going to be wrong. A more conservative approach, as I try to explain, is to somehow keep track of all the reward functions that fit the data. Now, why would you go to such extremes, if I could say so? Because the stakes are high. Because these hallucinations where the system thinks it's doing well, but actually is doing something really bad, can be highly consequential for society. Maybe something like shorter term than the loss of control that I've been talking about is misuse. So now for like years, companies have been trying to put all kinds of instructions and safety tuning and RLHF and all kinds of techniques to try to make sure that if you ask one of these LLMs how to build a bomb, for example, it will not tell you. Unfortunately, all of these attempts have failed. And there are two recent papers, for example, that just for a few dollars, you can fine-tune these an open source system so that all the safety protection goes away, and you can then ask it to do whatever you want.
Great, thanks so much. Okay, opening the floor to Q&A. Any questions? Okay, whoever is virtually. Okay, let's do someone in person in this room, and then we'll get to the Zoom questions. Okay, yeah, go ahead.
Can I just say here?
Yeah, just speak loudly.
Hi, thanks for your talk. Do you perceive any tension between open source models decentralizing power and the positive that open source can bring, and the call for regulations of AI models. How would we navigate this tension?
Yeah, as you say, there's a tension. There's a major tension. So I've been a big proponent of open source for all my career, and open source has a lot of advantages. It speeds up progress, and it actually, for example, in case of cybersecurity, it helped to make our systems safer. So you might think, oh, well, it's good. It is a form of democratization in the sense that more people can have those tools. But let me use an analogy here. There's another form of democratization where everybody has access to something dangerous. It's called no gun control. It doesn't go well. So what are our options here? Like you have to think of these systems as they get more powerful, can be useful or they could be dangerous. And the question really from a democratic perspective is who decides whether we release a system open source or not. What kinds of systems we want to share because the benefits outweigh the risks, and what kinds are not socially acceptable. Who should take those decisions? Corporations or governments? So if you think the answer is governments, then you want a regulator to be able to say no sometimes to open source when the disadvantages to society are greater than the advantages. And the radical open source is basically like a libertarian solution that says, oh no, we should all have the right to bear arms. Let us do whatever we want. And when I decide to open source something, it's my decision. And if you don't agree, do your thing. But unfortunately, those decisions may have consequences for everyone. Like if we release something that can then be used by terrorists to create lots of harm in our society, then we all pay for that. And I think it should be collectively that we decide what should be released and what should not be released.
Thank you.
If you are a virtual attendee and have a question, please ask it in the Q&A. Don't raise your hand. We're not going to call on you. Just type your question.
Yeah, let me add a couple of things here because this is such an important question. I'm sure there'll be others on that front. So as I said, open source has advantages, and for these more powerful systems that are too dangerous to be released according to the public, we would still like to have those advantages. And what can we do? So for example, one thing that is being proposed that I think is very interesting is to create secured enclaves, sort of what's called structured access, by which scientists who are trusted can have access, and they would not have access to the weights, but they could still do a lot of research on these systems. So the point is, we might find technical solutions or socio-technical solutions that allow independent third parties to develop and understand these systems and find failures without making them open to bad actors and everyone. So that's an example. The other thing is that has been raised by people who are pushing for radical open source is that it's going to help against concentration of power in the hands of just a few companies. And that's, I think, a very important point, because as I said in my talk, concentration of power is a big concern. So what can we do about this? Well, there's other solutions in open source to avoid this effect of concentration of power. We can have democratic governance. We can make sure that the organizations that are building these very powerful systems have to respond to representatives of our democracy or democratic process of how these systems are built, how safe they are, what purpose they're used for. And ultimately, I think that there should be nonprofit organizations working towards the development of AI for the benefit of all, like in healthcare, the environment, and so on. That would also follow the same sort of governance constraint. It doesn't have to be limited to 3 big companies.
Great, thanks. Okay, other questions? Let's take one more from Harvard. Okay, I'm going to ask a question that I liked from the virtual Q&A, which was, so you propose gating AI actions by an AI scientist, which is trying to estimate probability of harm within an action. The question was, what if this AI scientist's reward is misspecified? What I think there's no reward.
There's no reward for the AI scientists.
Sorry, maybe I
So
should say, what if it's like labels are misspecified or something? Like, how, like we now have like
there are
another.
no labels. There are no labels and there are no rewards. The way the AI scientist is trained, the reason I use this term, AI scientist, is that it's trying to understand the world. It's trying to understand the data that it has. And the way that it tries to understand the world is forming theories, just like we do. So if you want, it's going to write thousands of papers to explain the data you give it, the data that it sees on the internet or whatever. And that's different from trying to achieve an objective. It's just, and in Bayesian terms, it's just trying to come up with a distribution over theories proportional to prior times likelihood. But at the end of the day, it's forming an understanding of the world, including all of the possible explanations that are compatible with the data and are reasonably small.
Okay, thanks. That's helpful. I guess, I mean, so it does need to have a concept of harm, which coincides with our concept of harm, because we're creating it. What's the probability that this thing is harmful? Presumably, according to us. So how do we make sure those concepts are aligned?
Okay, this is a great question. In fact, it's one of the central, I think, research questions that need to be tackled. So how do we make sure that it's, when we say harm in the query, like, is it going to be harmful? That how do we know that it's corresponding to what we intend? And we don't. And that's why you want to be Bayesian, right? So it's going to entertain all of the theories that humans entertain, plus all of those that it also finds that fit the data, and give them different weights, at least conceptually. And if you want, if any of these plausible theories say there could be substantial harm, then it will say no, don't do it. So it will not know. Like, we should just let go of the idea that we'll build an AI that knows what is harm. Now, the more it gets to build good theories and its sees enough data about human psychology and how we behave, the more it might understand our psychology and how different people react to different situations and so on. So it might get better at it, but we should just let go of the idea that it actually knows what harm means, and then you can get something safe.
Great, thank you. Another one from a virtual participant. This question was by Janet Egan. The question is, it seems like the vast majority of AI expertise is held and developed within the labs. How do governments go about building expertise in AI without being caught by regulatory capture?
Well, they need to build the AI muscle. Governments have a lot of muscle when it comes to dangerous stuff like dangerous pathogens or like nuclear material. And AI is going to be highly transformative and very powerful. And I think governments need to build that muscle. Right now, maybe it's going to be logistically difficult for governments to hire the right people, but I think that they should. They could also work with nonprofits who could, recruit AI researchers and engineers. But ultimately, I think it's going to be in the hands of governments. And actually, it should be also the international community, because there's also a lot of kind of a geopolitical situation and reasons to share that power across the whole planet somehow.
Great, thank you. Okay.
I have a question. Can you hear me? No.
Yes.
So my question is regarding human oversight. A lot of regulations suggest human oversight, and a lot of these systems are not actually autonomous in the wild. So what do you think of like the human role in kind of mitigating the risk, and how do you see the human kind of supervising these systems? And
yeah. Well, depending on the potential harm that could come out of a system, I think we should require or not to have human oversight before these decisions are taken. It's obvious that in sort of the large scale deployments, you can't have a human decide for all of those decisions. But maybe the right answer in those cases, if the potential for harm is too high, is to say, sorry, you can't use the AI until you can demonstrate that it's going to be safe or not less safe than if a human were to take the decision. Ultimately, I think the moral questions should be in the hands of humans, whether it's in direct intervention, like it is the humans who take the actions in the world that could be harmful and taking responsibility for that, or whether it's in the ways that we provide the governance of these systems, or in the ways that we try to train them so that they understand what is right and wrong, which is going to take some time. We're not there yet, but I think we should go in that direction. And who decide what is right and wrong? Again, it's going to be humans, right? We should be the ones controlling all of the moral questions.
All right, MIT, let's give it another try.
Hi, can you hear me?
Yes, perfectly.
Yes, Henry Lieberman, MIT CSAIL. We're getting echo on our end here. So maybe we have to rethink the idea of self-preservation, or what that means, or you have some self-motivation. In Isaac Asimov's 3 laws of robotics, the 3rd law was about self-preservation, but it came with an important caveat. Said that
That's right.
It doesn't contradict what a human told you to do, and it doesn't allow humans to come to harm. So I think that was very wise, So maybe that we have to think about that self-preservation motivation needs to be thought out very carefully. And the question is, who is the self? And if the self is just the computer without any consideration of people, then obviously that's very dangerous. But if the self is us, which is the system that comprises the human and the computer and some notion of human well-being, which might be a little bit debatable, but maybe we can get it to work that way.
Yes, I agree with you. I'll just add a kind of interesting note, which is that a lot of the Asimov stories were about the breaking down of the 3 laws because of funny interpretations you can make. So, as you said, in this process, we have to be extremely careful. But yeah, if we actually have robots that have a destructible body, then if they want, to be useful, they also need to make sure they don't self-destruct by doing something stupid for themselves, for sure. The other thing I would like to say is maybe a lot of the Asimov thinking was thinking of robots as like us with our bodies. But if you think about computers now, they're sort of immortal. I'm just copying Jeff Hinton here. They're immortal because they can copy their code and the content of their memory to another computer as many times as needed. So that's very different from us. I think applying the same notions that we apply to humans and other living beings to computers is something that can trick us, and we have to be really careful about what we are thinking.
All right, another question from the virtual Q&A. The question is, throughout history, weapon development has been secret. The military is already using AI weapons, which need to be aligned in a different sense. What do you think about the international military AI arms race?
Do I look like a geopolitics expert? This is really tricky, but what I think most experts will agree on is that we should try to at least minimize the arms race, the AI arms race. So again, AI, especially as it gets more powerful, gives power to whoever controls it, and it's obvious that the military will want to use this. So we should put guardrails, but of course, we want to make sure the other guys are using the same guardrails. How do we do that? I think that this is a difficult question. There are some proposals, but I don't think we're close to figuring it out. But at least we should lay it down, like start with something like what happened at the Bletchley Park in the UK AI Safety Summit, where at least we agree on principles that we should only build AI systems that are going to be safe in some sense. And that being said, I think what's going to happen anyways, so we should sign those treaties, but we should also prepare in case some bad guys, it doesn't have to be those who sign the treaties, it could be rogue states, some bad guys actually build dangerous AI systems. And how do we do that? Well, we need to do it in a way that it's not going to blow in our face. So we need to actually invest a lot of research in building better aligned systems, much better aligned systems, so that we can potentially use them for defense and not offense, in case we have to do it.
Okay, here's another virtual one from Max Nadeau. The question is, so sort of famously, your change of your mind came from seeing empirical results on scaling, or on how rapidly AI progress has gone. So this question is about, what are the sources of disagreement between you and your colleagues? Like, is it mostly empirical stuff like this, like how rapidly scaling is going? Or is it mostly conceptual stuff? Or like, why doesn't everyone already agree on this stuff?
Well, I think you need to bring more people around the table, but let me still try to answer somehow. I'm trying to be rational about all the pieces of evidence. I think before ChatGPT, I was looking the other way in terms of the potential dangers, because I thought, oh, this is decades or maybe a century in the future, and AI is going to be useful. Is going to be useful in the short term. Now, why do we disagree? Well, actually, we might not disagree as much as you think. So there are disagreements, but for example, people like Yann LeCun, Jeff Hinton, and I all agree that we could reach human level, capabilities for most tasks within a few years, or it could be a few decades. So there's a wide interval of uncertainty. It's just that how we react to this, like what should society do about it, we may disagree. But on the existence of potential very powerful systems and the existence of potential misuse, I think there's a lot of agreement. On the question of whether we could lose control, I think there is more disagreement. And my opinion on this is kind of agnostic. Like, I don't know, but I see the arguments on both sides, and I can't really deny the possibility that with AI systems that are substantially smarter than us, we could lose control. So I think it's all about also a question of where do you put your prudence, precaution level. And if you think it's very far in the future, like some other folks, then you say let's not worry about it and deal with the actual problems that are important and are happening right now. And I understand that, but I really don't know, and I want to be sure that my children and grandchildren have a life.
All right. Do you have any other questions at MIT?
Hello. Thank you so much for your talk. I had a general question about GFlow nets. So over recent years, there have been many different methods proposed to generate structured objects like graphs, like diffusion models or flow matching networks. And I was wondering what types of generation tasks GFlow nets might be best suited for, and when a researcher might consider using one over other types of methods.
Yeah. Yes. So the main distinction between GFlow nets and existing deep generative models is that what we use to train them is a reward function, or if you want, an unnormalized density function, like a black box you can call. Whereas typical generative models are trained by giving them a data set of good examples. So a reward function contains more information, like I can tell you that something is bad, not just something is good. And it gives you gray levels because your reward could be more or less big. So you're really solving a different problem with GFlowNet. And it turns out that this is the problem you want to solve if you want to build a Bayesian posterior, or there are other reasons why you might want to use GFlowNet, like you want to have a system. So initially we designed them to help us in scientific discovery to come up with a high diversity of candidate solutions. So if you sample from a reward function that's supposed to estimate how good a solution is to a problem, when you sample IID from that distribution, you will get a very high diversity of solutions. So it's a kind of a simple heuristic to find a bag of potentially good solutions to a problem when you're able to score a solution, but you don't know how to sample accordingly. So the GFlow nets will do that job for you.
so we're just about ready to wrap this up. Thanks so much for joining us. We're going to do one last quick question, which is, what's on your wish list right now for what to see in the field of AI safety, either in policy or in technical work? If there's a super intelligent genie that's magically aligned and comes down and grant you sort of like, what's the next step that you would like really want to see happen in 2024?
Okay, so I have two wishes, and we need to both in order to safeguard humanity. So one is around governance. We need governments to really clarify, have a very clear and simple basic principle regarding AI safety, which is that it is companies that should have the burden to demonstrate that their systems is safe. That's the number one thing. And in particular, as a side effect of this, in general, I don't think it's not going to be possible to prove that if you open source a very powerful and dangerous system, potentially dangerous system, that you can guarantee its safety, that it's not going to harm people. So it's immediately going to have an effect there. That's my second wish is technical, and that's sort of research that I'm doing and that I kind of highlighted, that we find machine learning methods that give us quantitative guarantees of safety. It sounds like I'm asking a lot, but ultimately that's what we ask of any other domain where very high risks are involved, like building a bridge or deploying a drug. And I have the intuition with the conjecture I showed, sort of highlighting it, that it is possible, but it might take quite a bit of more research. So I'd like to see more investment in these sort of probabilistically provable guarantees of safety and alignment, which I think we will need in any case, because regulation is not going to be 100% protecting us.
Thanks so much. Let's give Professor Bengio another round of applause.
Thank you. Thanks for having me.